Today we are going to continue solving rational equations. So again, what we're going to do is we're going to eliminate the fractions by multiplying the entire equation by the LCD. Now, what's going to be different today is we must check our answers for extraneous roots. And what this means is when there's a variable in the denominator, that's when you need to check your answers. So if your answer makes the denominator a 0, then you throw that answer out. And then if that's the only answer you have, because these are linear, your answer is going to be no solution. And again, on WebAssign, you key it in as a DNE. So let's go ahead and try our first example. Now, notice on this one, it is a rational equation, but notice there are no variables in the denominator. So once I solve this one, I'm not going to have to check. The only time you have to check for extraneous solutions is when the denominator has a variable. Now you can still do the check to make sure you got the right answer. Now, just like yesterday, I'm going to clear my fractions and I'm going to multiply every single piece, every single term by the LCD. So I need to find the least common denominator from 3 and 4, and that's going to be 12. Now, if you want to treat this as just taking it and saying I'm multiplying the whole equation by 12, and you're going to distribute it to each piece, or if it's easier for you to just show that I'm doing 12 times x over 3, and then 12 times 3x over 4, and then 12 times the 2. If it's easier for you to see it that way, so that way you can show the simplification process. Here I'm left with 4x. Here this will turn into a 3. And then lastly, this is a 24. Now my goal here is not to get a denominator of 12. I'm trying to eliminate the denominator. So that's why I'm multiplying each piece by the LCD to get it to simplify. Now I'm going to combine my like terms. These are on the same side of the equal sign, so I'm just going to add them. And now my next step is division. So I divide both sides by 13, and I get x equals 24 over 13. I'm okay with you leaving it improper. You don't need to make it into a mixed number. Now, if ever you're doing it on WebAssign, just read how they want the answer inputted. If they say to write it as a simplified fraction or a mixed number, just read what it's asking for. Now, there is no need to check this answer because there is no variable in the denominator. However, you can plug it back in for x to see if it gives you, if this left side equals 2. But this is the correct answer. We're good here. The next one, same thing. I don't need to check number 2 because, again, there's no variable in the denominator. You can think of this 5x as 5x over 1. I need to find the LCD between 5 and 3, and that's going to be 15. So, again, either think of distributing the 15 to each piece, or if it helps you to see it better, just take it and write it next to each one. So maybe you can see this simplify. But you don't have to do this. Whatever method is going to work best for you. So I'm going to simplify the 15 and the 5. This becomes a 3. So 3 times 2x is 6x. Nothing to simplify here. So I actually have to multiply 15 times 5, which gives me 75x. And then this simplifies. And then 5 times 4 is 20. And now I can combine my like terms. So 6x plus 75x gives me 81x equals 20. Going to divide. And I get 20 over 81. This cannot be simplified any further. So that's my final answer. Again, there were no variables in the denominator, so I don't need, it's not a mandatory check. Again, these answers are going to be fractions. They're not always going to be integers. Let's try the next one. Still no variable in the bottom yet. Not until we get to number 4. So again, if you want to put a 1 under the 3, and again, think of this as first finding the common denominator between 5, 2, and 10, and that common denominator is going to be 10. So again, think of this as multiplying each piece by 10. And again, I like to write it right next to it, just so I can see it a little bit better. So x over 5 minus 10 times x over 2, 10 times 3, plus 10 times 3x over 10. So again, simplify, and this becomes 2x. Simplify, this becomes negative 5x. 10 times 3 is 30. The 10s cancel, and I'm just left with a 3x. Now it makes it so much easier. I don't have to worry about working with fractions. So now I'm going to combine my like terms first. 2 minus 5x is negative 3x. Move my 3x over by subtracting it. And then I get negative 6x equals 30. Divide by negative 6, and x equals negative 5. Again, you can plug it in if you'd like to make sure it works. But again, the check is not mandatory here. Number 4, the check will be mandatory because I do have a variable in the denominator. Now, when it's just an x in the bottom, the only thing that would make this undefined is when x is a 0. So if I get x equals 0 as an answer, then my answer would be no solution. So let's go ahead and start our solving process. So again, I want to get x out of the bottom of the fraction. That's my LCD. You see, this is a 1 and a 1. So my least common denominator here is x. And that's what I'm going to multiply everything by. So x times 15 over x times 4, and then x times 6 over x, and x times 3. So again, this will cancel, and I'm left with 15. This I just multiply. This will cancel, and then I multiply. Now I'm going to group my like terms. Now, if you want to move the 4x to the right, you can. Again, there's no rule that says you always have to move letters left. Some people like that. It's up to you. So subtract 6. And now I get 9 equals 7x. Divide by 7. And x equals 9 over 7. Now, what I'm checking here is when I place this answer in the bottom of the fraction, I'm not trying to do the whole problem. You can, but what I'm trying to check to see is when I plug it in, if it makes the denominator 0, then this problem is undefined. But because there's nothing to add or subtract to that, 9 over 7 is a good answer. So I don't have to do the whole problem. If you want to do the whole problem to make sure the left side equals the right side, you can. But again, your goal is just to make sure that this denominator is not a 0. And it's not. It's 9 over 7. So 9 over 7 is a good answer. So if you remember back when we were doing this in the other chapter, in the prerequisite chapter, it had all those excluded values that I told you to ignore. Now we have to include them or do the check for it. So this answer of 9 over 7 is good. So let's try another one. And we'll see where it's not going to work. So number 5, again, this time, when I have something that looks like this, and it's just two fractions equaling each other, I'm going to just treat this as a proportion. And I'm just going to cross multiply. So I'm going to just do this times this, and this times this. So I'm just going to set it up as 2 times 10x plus 3 equals 5x plus 6 times 1, which is just 5x plus 6. So this side I'm going to leave alone. And then I get 20x plus 6 equals the 5x plus 6. Now what I need to do is start moving my terms together. So subtract 5x, 15x plus 6 equals 6, move the 6, 15x equals 0, divide by 15, and x equals 0. Now, when I go to do the check, because I do have a variable here in the bottom, when I plug in 0, right here, and when I do 5 times 0, I get 0, but then when I add 6 to it, it doesn't make the denominator 0, it makes it equal 6. So this is still a defined problem, so it's okay. So x equals 0 is a good answer. If my problem would have been 10x plus 3 over x, just a single x, that's when I would have said, when I plug it in and this becomes a 0, then this answer is no solution. Because I can never, ever have a 0 in the bottom of a fraction. So that's all we're doing, is checking to see if our answer for x makes the denominator 0. And in this case, even though x equals 0, it didn't make the denominator a 0. So it's a good answer. Let's try the next one. Now, this time, we've got an addition happening on that left side. So again, I need to find a common denominator. If you recall before with the expressions, the common denominator is going to be both of these. Remember, you just can't add the minus 5 to it. So what I'm going to be doing here is multiplying the entire equation by x times x minus 5. So again, if it helps you to write it next to it, so x times x minus 5, I'm going to multiply that to the 1 over x. I'm going to multiply it again to the middle one. And then finally last to the answer. Okay, so again, we're looking for things to cancel. So see how the x's cancel? And then 1 times x minus 5 is just x minus 5. Over here, the x minus 5s are going to cancel. And then I'm left with x times 2, which is 2x. And then the answer, anything times 0, is 0. So now I can combine my like terms. So 1x plus 2x is 3x. And now I can solve my simple two-step equation by adding 5 and dividing by 3. So x equals 5 over 3. So now what I need to do is take this, come up to the top, make sure it doesn't make any of the denominators a 0. So when I put 5 over 3 here, it doesn't make that denominator 0, it just makes it 5 over 3, so that's good. And then also when I put it here, 5 over 3 minus 5, it's not going to make that 0. It'll make it a negative number, but that's okay. So 5 over 3 is a good answer. The quickest way that you could also check for your excluded values is take your denominators, make an equation for them. So like if I take this and say x can't equal 0, and then if you take this one, x minus 5 cannot equal 0, and then what you do is you add 5, So if you got x is equal to 0 or a 5 as your answer, then know that that's how you could throw it away. So that's another way that you could figure out what values need to be excluded. And if your answer ends up being one of those, throw it away. Let's try the next one. So again, my common denominator is both of these. So what I'm going to be doing is multiplying my entire equation by the 2x plus 1 times the 2x minus 1. So again, if it helps you to write it next to each of the fractions, I'm just going to put it on top of each other just to save some room here. So I'm going to multiply it to the first fraction, 2x plus 1. And then I'm subtracting this. And then what you could also do on this subtraction problem is do like a keep flip change here. Turn this to a plus, make that a negative 8. So then 2x plus 1, 2x minus 1, and it gets multiplied to the negative 8x over 2x minus 1. And then lastly, same thing to the answer, 2x plus 1 times 2x minus 1, and then the negative 4. So now let's look for things to simplify. So the 2x plus 1 is gone. So now I just have to distribute the 7. So let's just write it like this first. So I'm going to do 7 times 2x minus 1. That's what I'm going to be doing. And then here, the 2x minus 1 cancels. So here what I'm going to be multiplying is negative 8x times 2x plus 1. And then for the answer, nothing cancels. So I'm going to be multiplying negative 4 times 2x plus 1, 2x minus 1. So now I need to distribute, start combining like terms. So 7 to the 2x, 7 to the negative 1, 14x minus 7. Distribute this here. And this gives me negative 16x squared minus 8x. And then to the answer here at the end, I probably can do this in 2 steps. You can either FOIL the binomials first, or you could distribute the 4 first, either way. So if I distribute the 4 first to the first one, I get negative 8x minus 4, and now I got to FOIL it with that one. This is not showing up too good there. So let me just FOIL that, and you get negative 16x squared minus 8x. Actually, I'll do plus 8x, and then minus 8x, so outside, inside, and then last, positive 4. So notice these two are going to cancel out. So let's start combining like terms here on the left side. So nothing to combine with this, so just the negative 16x squared. And then I can combine the 14x and the negative 8x, and that gives me positive 6x. And then nothing to combine with the constant, so I'm just going to write minus 7. Then over here, I have the negative 16x squared plus 4. So now what I need to do is get my terms together. So if I add 16x squared to both sides, notice it cancels. So now I'm left with 6x minus 7 equals 4. Add the 7. And I get 6x equals 11. Write it over here. 6x equals 11. I know it's hard to see. Divide by 6. So x equals 11 over 6. Now, I need to go back and plug that in. So here is where it might be helpful if you started by taking the denominators and say, well, if 2x plus 1 cannot equal 0, if I get an answer that equals -1/2, then I would throw it away. And then the same thing on the other one, if you did that, 2x minus 1 cannot equal 0, add that, 2x can't be equal to 1/2. So these would be the two answers that would make this one no solution. But again, you could also take these two things and take 2 times 11/6 plus 1, and this would give you 22/6 plus 1. This is not going to be a 0. Same thing here, 2 times 11/6 minus 1. So notice that neither of these, when you plug it in, make the denominator a 0. So 11/6 is a good answer. Let's try number 8. This is where it's going to fail. Now, again, when you're finding a common denominator, don't leave it unfactored, that denominator, because if you don't factor it, you're going to end up with a really huge, ugly problem. So what we're going to do here is factor the difference of two squares into x plus 2, x minus 2 first. Then you can see that in that difference of two squares, you have part of the denominator hiding there. So what I need to do is my common denominator is going to be both of those, x plus 2, x minus 2. I don't want to say that my common denominator is x minus 2, x plus 2, and x squared minus 4, because this thing is made up of these two. So my common denominator, or my LCD, is just this part of it. Don't repeat it. So let me go ahead and, oops, let's set this up now. So again, I'm going to be multiplying my whole equation by the LCD, which is the x plus 2 and the x minus 2. Now again, if you don't like to write that same thing in front of each one, you don't have to. You can actually do this as just showing it, and you could also distribute it as the x plus x squared minus 4, if you'd rather, which might make it a little simpler. But we still would have to go back. Actually, let's do it the other way. Just realize that this x plus 2, x minus 2 is equivalent to this when we get to the last part. So I'm distributing x plus 2, x minus 2. So just to show you that you don't have to write it next to each one if you don't want to. It just helps me see it when I go to cancel. Now what also is going to help me is if I do a keep flip change here with this subtraction and make that plus and make that a -6x. Now, when I go to distribute this to this, notice the x minus 2 cancels, and then I'm just left with multiplying x plus 2 times 1, which is x plus 2. Now what I need to do is distribute that thing to the next term. Do you guys like doing it like this without having to write all that stuff, or do you like writing it next to each one so you can cancel it? Anybody have any preference? No? All right. So when I go to distribute it now to this one, notice the x plus 2 is going to cancel. So then what I'm multiplying the 3 by is the x minus 2. So for the next one, it's going to be 3 times x minus 2. And then when I go to distribute it to the last one, notice they both cancel out. So then I'm just left with the plus -6, or the -6. It doesn't matter how you write it. So now I need to distribute this. Actually, I can drop the minus. And now I need to start combining my like terms. So I have like terms here that I need to group first. So I get x plus 2 equals negative 3x minus 6. I'm going to move my 3x. And now I'm left with 4x plus 2 equals negative 6. Going to subtract the 2. 4x equals negative 8. Divide by 4. And x equals negative 2. I need to check it because if it makes any of the denominators 0, I'm going to throw this out and my answer is going to be no solution. So let's go back to the beginning. So I need to plug it in to x minus 2 and x plus 2. So x minus 2, when I plug that in, it gives me negative 4. That one's okay. But when I plug it into the x plus 2 denominator, I get negative 2 plus 2, which equals 0. It's making this denominator here a 0. So this answer is bad, and the answer is no solution. On WebAssign, key it in as DNE, does not exist. So there is no value of x that would make this equation true. Number 9, same thing. We need to find the common denominator. My common denominator is just going to be x minus 4. This one's a little bit easier. So again, I'm multiplying the whole thing by x minus 4. I think it's a little bit easier to see when I write it next to each one. But again, you don't need to. I just wanted to show you on that last one that it is not necessary that you do that. So again, write the x minus 4 next to the 5. And then write the x minus 4 next to the fraction of 12 over x minus 4. All right, so again, look for things to simplify. This is gone. And then now here you're just left with 3x. Here I have to distribute the 5 to both. So 5x minus 20. Here it cancels, and you're just left with 12. Combine your like terms. So before I begin moving things across the equal sign, let me combine those. So 3x equals 5x minus 8, and now I'll move my x's together. And I get 8x equals negative 8, dividing by 8, and x equals negative 1. I need to check it to make sure that it doesn't make the denominator a 0. Did I do something wrong? Let me see here.
Isn't it supposed to be
Minus 5x, yes. All right, this should be subtracting 5x. Let me go back. Thank you. All right, so I'm subtracting 5x, which gives me a negative 2x equals negative 8. And then when I divide by negative 2, I get x equals 4. And then when I plug it in, notice when I plug it in right here to x minus 4, 4 minus 4 is 0. Makes this denominator and this one 0. Soon as it makes just one of them a 0, this answer is bad, answer is no solution. So on the quiz or the test, you can put that 0 with the slash, or you can write out the words no solution. But again, remember on WebAssign, it's DNE. Now, again, if you would have rather tried to figure out what was the excluded values right from the beginning, remember you just take that denominator and you would have said x minus 4 cannot equal 0. And then when you add 4, you get it cannot equal 4. So if you got that as your answer, you would know to throw it away. Let's try number 10. This one's a little long. It's actually the common denominator is both. So I need to multiply each one of the terms here by x minus 1 and x plus 3. So x minus 1, x minus 3 gets multiplied to 12 over x minus 1, x plus 3. And then here, same thing. Multiply this one by x minus 1, x minus 3. And again, they should be side by side. They shouldn't be a fraction. I know this is kind of misleading. Maybe just realize that I'm just trying to save room, that it's really side by side. Okay, and then here, x minus 1. And then here, x minus 1, x minus 3. And then it gets multiplied to the 2 over x plus 3. So again, this total thing gets canceled, so you're left with 12. Only one that cancels here is the x minus 1. So you're going to be multiplying 3 times the x minus 3. Here, the x plus 3 cancels, so you're doing 2 times x minus 1. And we're going to distribute.
X plus 3, right?
It's x plus 3? Thank you. Perfect. Good catch. All right, everybody good? All right, so you see how it's easy to make a little simple mistake, and then it's going to mess up your answer. So I know I'm trying to rush so I can beat the clock, but I know you're trying to always work fast, but again, little mistakes can happen, so just be very careful. All right, so 12 equals 3x plus 9 plus 2x minus 2. I'm going to combine my like terms, and I get 12 equals 5x. I could also probably combine these at the same time. 9 minus 2 is 7. And now I can begin to solve. I'm going to subtract 7, and I get 5 is equal to 5x. Divide by 5, and x equals 1. And again, I got to check it. And as soon as you try to plug it into this first one, 1 minus 1 is 0. Soon as it makes any piece of this a 0, this is a bad answer. No solution is your answer here. So you're not having to plug it in and completely solve the whole problem. Does that make sense? So don't worry about simplifying everything. All right, next one. Factor the trinomial first. Don't think that your LCD is all 3 of these. Otherwise, your problem's going to get really ugly. So after I factor this one's actually going to factor into x plus 3 and x minus 2. So that's just my LCD. It's just those 2 binomials, not all 3 of those denominators. So again, I need to multiply all 3 pieces. Now, if you'd rather try to, fit it in here, show that you're doing x minus 2, x plus 3 next to each one of these, you could do that as well. Again, it helps me to put it right next to it. So you can see here that the x minus 2 cancels. So 1 times x plus 3 is just the x plus 3. Here the x plus 3 cancels. And then you have to distribute the 3 to the x minus 2. And then this one, everything canceled, so you're just left with 4. Again, I'm going to distribute. So I get 3x minus 6 equals 4. I'm going to group my like terms together here. So that gives me 4x. And then 3 minus 6 is negative 3. And then it still equals the 4. Add the 3. 4x equals 7. Divide by 4. And x is 7 over 4. Now, if you look, the only thing that's going to make my denominator a 0, if you wanted to take these things and say, well, I'm just going to take x minus 2, set it not equal to 0, and x plus 3 not equal to 0. When I solve this, x can't be a 2, and x can't be negative 3. Well, the answer I got was 7 over 4. So that's not going to make anything 0. So this is a good answer. Or, again, plug it in up here. And again, 7 over 4 minus 2 doesn't give me a 0. And 7 over 4 plus 3 doesn't give me 0. So this is a good answer. One last question. And again, factor the denominator first. So this is actually going to factor into x times x plus 3. So again, you can already see that this one's got a piece and this one's got a piece. So this is your LCD. So again, I'm going to multiply each piece by this LCD. And again, if you want to just write it up top here, x times x plus 3, x times x plus 3, x times x plus 3. So again, we're looking to cancel, so the x's cancel. So I just have to distribute 6 to the x plus 3. And then here, negative 2 is going to get distributed just to the x. And then here, everything cancels. So you're just left with 3 times x plus 5. So now distribute. And now combine my like terms. 6x minus 2x is 4x. Move my x's together. Subtract. And then move the 18. And x equals negative 3. I need to check it. And again, soon as I plug it here, this works. But if I put a negative 3 plus 3 here, this makes this a 0. So this answer is no solution. So that is it for the 1.2b. Again, the homework's not due till Monday. What you should do tonight is practice factoring. You're going to get 8 factoring questions. There is a web assign that I posted. Again, you can also go back, use your quiz reviews, use your test review, go back and do the factoring homework, go back, look at the factoring notes, anything you can get your hands on to practice factoring. Khan Academy is another good way to practice factoring. Again, we will factor all year long. So that's why we're throwing in this extra quiz to make sure you've got a good grasp. So there'll be difference of squares, difference of cubes, sum of cubes. There will be trinomials, simple trinomials, perfect square trinomials, and even the more challenging trinomials where there's a number in front of x squared. There will also be factor by grouping. Key thing to remember, always, always, always look for a GCF first before you start your factoring process. If you forget and you see that there's still a common factor in there, go back and restart all over again. But always, always, always look for a GCF first. Another key thing to remember is when you factor the perfect cubes, that trinomial in that pattern will never be able to be factored any further. So just little key things to remember. If you have time, FOIL your answers or multiply your answer back. It should go back to the original problem. If it doesn't, you've done something wrong. If you factor a GCF out at the very beginning, don't forget to put it in your answer at the end.